Hey guys, this is Taylor and today we are solving third problem of weekly contest 466. Let's get started. So this is 3676 problem, count bool subarrays. You are given an integer array nums with distinct elements. Okay, so just to carefully note, we have distinct elements. A subarray nums of num is called a bool if subarray has at least length of 3. So length should be at least 3 and the minimum of its two end minimum. Okay, minimum of two end means what is the leftmost, what is the rightmost. Its minimum is strictly greater than the maximum of all elements in between. That is, minimum of left comma right should be greater than strictly greater. Okay, it can't be equal, it should be strictly greater than max of nums of l plus 1 till nums of r minus 1. Return the number of bool subarray in nums. Let's see what is given to us. So 25314, 25314. Okay, so if I pick up this array, let's say this one, can I say this is a bool subarray? Why? Because 3 and 4, what is the minimum? We have to take minimum from the ages. So minimum of its 2 end. So what is minimum? I think minimum is 3. Superb. Is the minimum greater than whatever is present in the middle of this? So yes, condition satisfies this. I can say it's a bool subarray. So we have this second example. In this example, if you carefully see this part, this subarray, what are the ages? Ages are 9 and 8. What is the minimum of 9 and 8? I think 8 will be the minimum, right? Can we check 8 is greater than all of these middle elements? Yes, 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 yes. So yes, this can be one of the bool subarray. So I hope problem statement is clear. What is bool subarray? Bool subarray is basically whatever the minimum of left side and right side. So if you carefully see now what is given to us, we have to take left or right such that whatever elements are present in the middle should be less than this and this. It should be less than both of them. If it is less than minimum of them, that means definitely it will be minimum than max of them, right? So what carefully, if you see now, what we have to find subarrays where left part and right part is greater than all of the middle elements. If I tell you easily in easy terms, that is what given the definition of bool subarrays. So I hope question is clear. Let's try to find out bool subarrays in this. So 531 25314. So 314 is definitely a bool subarray. I think 5314 is also a bool subarray because minimum of 5 and 4 are greater than this 3 1. So 5 and 4 are greater than this thing. Okay, so yes, there are two answers. If we carefully see this one, so let's see. 512 is one of the answer. How 512 is answer? Because 512, 5 and 2 are greater than this one. Definitely it is a bool subarray. Next answer we have is 5123. So 5 and 3 are greater than 1 2. Yes, it can be. And similarly 5 and 4 are greater than 1 2 0. So this is also a bool subarray. And we have been given that all numbers are distinct. So we don't have to check whether both numbers are 5. So that's not a problem. Okay. So strictly greater, it's not a problem. Okay. Super. Similarly here, if you see, so I think there are no pools arrays because this array is in the decreasing order. So this is some huge number, I think 10 to the power whatever it is, 9 I guess, and then minus 1. So this is not a bool, there is no bools arrays, we have written 0 here. Super. So here I have another example. We will try to find out bool subarrays in this. Okay. So let's try to see how many bool subarrays we have. So if I can see, so I think this can be one of the bool subarrays because 3 and 4 are greater than all of this number. Another bool subarray I can find out is this one. So it's your task also. So in this part, tell me, okay, how many bool subarrays can you find? So pause the video and just try it out. Otherwise, it would not be easy to understand things. So I think this can be one bool subarray. Yes, I can say this. Another bool subarray is if I include this number also, this can also be bool subarray. But this ages are higher, like large number, and this inside numbers are smaller. So I hope the definition of bool subarray is clear to you. So whatever the age is, we have to compare with the middle numbers. If ages are greater than all of the middle numbers, then we can say that subarray is a bool subarray. So we very well know what is bool subarray. Now let's try to find out, okay, what is brute force solution to this problem. If we are able to find out brute force solution, then it will be easy for us to move to little optimal than the most optimal solution. And let's start. So, what can be the brute force solution? What will be the most naive approach to solve this problem? What do you think? Uh, what I'm thinking, what's coming in my mind, the first thing is I need to find subarray of size 3, right? So, something like two pointers can help me because I can maintain a two pointer. I can keep counting all subarrays which are at least of length 3 and greater. Okay, it should be at least length 3 or greater, and I will try to find out every subarray. I will try to find out every subarray of length 3 or greater, and I will check brute forcefully whether the condition is satisfying, whether the ages are greater than the middle elements. This is the most new approach. Okay, let's see what we can do. So what I am thinking is I will start a pointer from here. I will move next. I will put next pointer here. No, I will not. I will put here. Why? Because I need at least size 3, right? I need at least size 3. If I put at 0, so I will put it not like if I am putting at I, so I will put the next pointer at I plus 2 so that my array size can be at least 3. Okay, I will check whether the ages. I will take the minimum. Okay, minimum is I think 1. I will start iterating in the middle. I will iterate over all of the elements in the middle. I will check whether this number is smaller than this age number. If that is true, and I am able to iterate over all of the elements, all of the numbers in middle, then I can say I can increment my count. Okay, yes, that I found a bool subarray. In a case, let's say this case where 2 is not smaller than 1, so I can say that okay, this is not a bool subarray, and I will move my window. Okay, I will move my pointer. So this pointer will move here. Now again, so in this case, what is the case? So my count is still 0. I will move my pointer here. Now I will check. I will check from here. Yeah, is this what is the minimum? First of all, minimum is 3. Is this 2 less than minimum? Yes. Is this 1 less than minimum? Yes. So my middle size, like middle elements are completed. So I can say yes, I found a bool subarray. I can increment my counter. Now I'll put my count, like put my second pointer here. Similarly, I will try keep calculating for all of the number. Now, what is the next step that I will do after completing all of this? I will move my left pointer here and another next pointer here at I plus 2. Okay, so initially if you might have guessed, I will start a loop from I equal to 0 to n. I can definitely write inside this I can write another loop which will start from I plus 2. Okay, so j will be starting from I plus 2 to n again, and inside that what I need to do, I will find the minimum of ages. I'll try to find minimum of ages first of all. Second thing, I will try to find out key what is a max element in the middle. Okay, max element of middle, and I will compare if max element is greater than, I mean max element, if max element of middle is what, 2, is less than minimum element of ages. If this condition is satisfying, then I can say that I can found a bool subarray. Okay, I hope the terminologies are clear. So things are little confusing. What we are doing, we are trying to find out the max element of middle. Why max element of middle? Because we have to make sure that all of the elements in the middle are smaller, right? So I will not compare from all of the elements. I will just keep track of the max element. While I will iterate now, I will move this pointer like this, like this, like this. I will just keep track for what is the max element. So the task will be easy for me. I will just keep track what is the max element. If this is the max element, If this is less than the minimum element, then all of the smaller elements than 2 will be obviously similar or obviously smaller, right? So I hope this brute force solution is clear to you. What I'm doing, I'm just tracking the max element of the middle. Okay, how I will be doing that we will write code in shortly, but I will keep track of the max element and I will just check whether the max element is smaller than the minimum element of the edges. Okay, now let's see how we can keep track of the max element of the middle. Okay, let's try to find out. So I know one thing for sure that my my this outer loop, it will start from this, it will go to this, it will go to this, it will go to this, like this. Okay, it will work like this. And my the next like the inner loop, my inner loop will start from I plus 2, so it will start from here. If my I was here, let's say, so it will start from here, right? So can I see a sliding window here? Yes, definitely I can see. What I can do is basically I will put my I pointer here. Okay, I will put my J pointer here. Okay, and I will tell, okay, what is the maxi currently. So maxi currently is 2. Super, maxi is currently 2. I will check what is the minimum of I and J. Minimum of I and J is, I think, 1. Is 1 greater than 2? No, it is not. So I will say, okay, no, this is not a valid answer. I will remove this J pointer. I will put this J pointer here. But before that, I will compare this element and this element. I mean, I will compare this element and this maxi. What is the maximum? So 2 is still maximum. So I will keep things as it is. I will check now. What is the minimum? 3 or 4? So I think 3 is the minimum. So I will put 3 here. Is 3 greater than 2? Yes, it is. Yes, it is. So I will say I got one bool subarray. Superb. So let me increment my counter. It will be initially 0. It will become 1. Now here I will check. I will move to 7. Okay. Let me remove this part. So my I is still at 3 and my J is at 7. Superb. Now I will compare the maxi. So this time my maxi will become 4y. So internally, after moving J, I will check what is the last J, what is the J minus 1. Whatever the J minus 1, I will compare that with my maxi just to update maxi. If I am able to update maxi, so you can see I was able to keep track of the maximum, right? When I am here, when I am at the jth pointer, I know, okay, what is a maxi? 4 is a maxi. If let's say 5 was present here, na, so I am keep updating. So I will keep track of the maxi in a constant time. So this will become my order of n square solution. This is not the most optimal, but it is better than the order of n cube solution, which we discussed very brute force. Na, okay, we will just keep these two pointers and we will keep going to find out the max element. So we'll don't need to actually again run a loop. We can keep track of this maximum like this. Okay, so let's try run one more time. So let's say my I pointer comes here. Let's say my I pointers come here. So definitely I will start J pointer from here, right? So my maxi I will reinitialize with what? J minus 1. So whatever J minus 1, I will put it here. Super. Now I will check, is this a correct bool array? Sub array? Yes, it is. Because minimum is 6, which is greater than 5. Yes, it is bool sub array. Super. I will move my J pointer here, but before I will move my J pointer here, but before that, I will update my maxi. 6 and 5. What is maximum? 6 is maximum. Let me update it. I will check. Is this bool subarray? Let me check what is the condition. 7 and 8. What is minimum? 7 is minimum. And middle elements are greater is 6. So 7 is greater than 6. Yes, it is. So max yeah. So I again got a bool subarray. So I will move my J pointer here. But before moving, after moving, I will keep updating my maxi of middle. So what is the maximum? 8 is the maximum. I'll just compare with the last J minus 1. Okay. So so now I will check what is the minimum. 7 and 9. What is the minimum? 7 is minimum, right? So what is the max of here? I think 8 is max. So this is not a bool subarray. Okay. So I hope you got it. Ki what we are doing, we are just keeping track of our maxi, and that's how we will be find out the solution in order of n square solution. Let's try to write this solution. I'm not writing pseudocode for this because otherwise video will become very large. So let me quickly write the brute force solution, then we will see how we can optimize it to make a order of n solution, order of n time solution. So I will initialize my uh, I pointer from 0 to n minus 1, and my j will be definitely starting from I plus 2, right? Yes. And my maxi will be initialized with nums of I plus 1, you can say, j minus 1, you can say, it's your choice. Now I will say while j is less than n, what I need to do? I will first of all define some counter variable here. Counter will initialize from 0. Now I will check if my minimum of nums of I comma nums of j, if this minimum is greater than what, maxi. So I can say I found a bool subarray. In case I am not able to find, what I need to do, I think I don't need to do anything, but still I will keep updating my maxi. So max will be maxi of maxi comma nums of j. Why I'm writing nums of j here? Because when we, like, I'm writing this after completing. So let's say I have completed this part. Okay. I have calculated, okay, this is a bool subarray. For example, this is a bool subarray. I have to find out this. Now I will move my pointer here. So next time j will be this. So currently I have to compare this with maxi, right? So that's what I'm doing here. Super. So in the last, I can just return my counter. Let's try to run this and see. Okay, I haven't incremented my j here. Okay, let's try to run this. Okay, I am getting one error. I should make it n minus 2. Why? Because n minus 2. So this will be the last number. This will be the last number which can find me a bool subarray. Can I start a array from here? No, because the array size will be 2, right? So I am going till n minus 2. So this is basically this is n minus 1. This is n minus 2. This is n minus 3. I can go till n minus 3. Okay, I can put a n minus 3 here, but I'm putting n minus 2. Why? Because this is Python for loop, Python range function. So this will exclude this last. Okay, so ideally, if you are writing in Java or JavaScript or C++, you have to go till n minus 3, right? But I have written n minus 2 because this is Python range function. This will exclude the last value. Super. Let me run this. It should work fine. Okay, let's try to submit and see whether this can be submitted or this will give us TLE. So it's taking a lot of time, and yes, it is giving us TLE. So what we can do, how we can optimize it, this will definitely give us TLE. If you can see the constraints are 10 to the power 5, and n square solution will definitely not work. So if you clearly see, we have a kind of n square solution only, where we are putting pointer here, then initializing this pointer and keep moving this, then we are putting here, then initializing here. Like this is this n square solution, perfect n square solution. Let's try to optimize this now. So let's talk about the most optimal solution for this question, which will be around order of n time complexity. Okay, so let's start. To find out the most optimal solution, we need to make few observations. So first thing to note, which is given to us in question, minimum array size would be 3, right? So we should definitely note this thing. We should keep this thing in mind. This is very important thing. Okay. Now let's try to make the subarrays. So first subarray that I can got is like something like this, right? Like when I was checking for brute force subarray, I got like this. How I checked whether this is a bool subarray or not. I was checking minimum of 3 comma 1, right? I was checking minimum of 3 comma 1, which comes to 1, and this condition was not satisfying because 2 was greater than 1. In that case, what I did, I increased the right part by 1. I increased the right sliding window by 1. Now I compared minimum of 3 comma 4, and this comes to I think 3, and this time the condition got satisfied. Okay, so this second wala part is yes. Now I moved once more. Okay, now again I checked minimum of 3 comma 7, and this comes to be I think 3. Okay, and the condition was false, so I didn't get a subarray. Okay, fine, we'll stop here. I want you to make one observation. If you can see this part clearly, 3 2 1. Okay, I let me write it here. 3 2 1, this part. Now can you tell me what is the minimum? What is the minimum? I think 1 is the minimum. Can, like, 1 is present on the right side or left side? This is very important. If 1 is present on the right side, what does that mean? What that means, left part is strong enough, left part is higher enough to tackle this thing, to tackle the middle elements, but the middle part is smaller, so that thing is fine, that thing is fine. What does that mean? That means I can find the higher elements in the right side which can satisfy the condition. I can potentially find, I am not sure. If I am looking only at this part, only at these two indices, I'm not very sure. Okay, the next element will be higher, but potential chances are there. But let's say we have array like this. In this case, my minimum element is on the left side. Okay, minimum element is on the left side. Are there any potential chances which can lead this part, some x, y, some this part as a answer? I think no. Why no? Because this is left part and this is middle part for this x. Let's say if I'm taking, let's say this part, if I'm taking, let's say this part, so this 3 is smaller than 4, which will which will not satisfy the condition. Let's say this x is 100. Okay, for example, so let me write 100 here, so for example. Now what is the minimum of 300? I think 3 is the minimum. This 3 is smaller than 4, right? So we want middle elements to be smaller, so this condition is not satisfying. So what is my observation? If my second observation is, if left is smaller, then stop inner loop, right? What is the inner loop? Inner loop, I was moving here, then here, then here, then here, right? So if I got something like this as inner loop, okay, so as soon as I got something like this, I will check whether left part is smaller or right part is smaller. In case right part is smaller, then that is fine, but in case left part is smaller, in that case I will not check for further J's. Okay, so let me make this change in our code, in our brute force solution, and see how does it providing any benefit or not. You can see 993 test cases are getting passed. Let me make that change. Okay, I will check if minimum of nums of I comma nums of j equal to nums of I, just in case my the left part, the ith part is minimum. In that case I can break the loop. Definitely I can break the loop. Let's try to run this. Okay, let me submit it and see. So carefully see, 993 test cases are passing. Let me try to submit this now and see whether we can whether we made some improvement or it's same thing. Let's check it out. 999. Okay, you can see we made some improvements, so 6 more test cases are getting passed. So it did something better, right? It did something better. So I hope the second observation is also clear to you. What is the first observation? First observation is we have to keep the minimum size, array size 3. Second observation is if left is smaller, then that part will be the last subarray which can be bold. There are no chances to make this as a bold subarray. Meanwhile, there are chances when we start from when we start I from here, that can be a bold array. This is a bold subarray, right? But there will not be a case if this is a bold subarray or not. No matter if this is smaller, if this is smaller, I won't be having a bold subarray like this or this or this. This will not be possible. I hope this is clear to you. Okay, let me clear down the screen. Now, the final intuition which I can give you to solve this problem is, if you carefully observe, what is our answer? I think this is our answer, right? 3214 is our answer. If you carefully observe what we are doing, you can see this 321 is decreasing, then we get increasing, and we got answer. Okay, another answer is this 214. What you can see? This is decreasing, then increasing. We got our answer. Let's see another answer. Okay, this is our answer. This is decreasing, 7 to 5 decreasing, then 5 to 6 increasing. We got our answer, right? Let's carefully see for this. Decreasing, then increasing. We got our answer, right? So what we can observe, the pattern is like decreasing and increasing. We don't have decreasing, increasing, decreasing. We don't have like this zigzag, zigzag, nothing. We just have decreasing and increasing. Where decreasing can be more than one, increasing can be more than one. So here we have increasing of three, but decreasing of one. But here we have decreasing of three, increasing of one. This can be possible, but we don't have a decreasing, increasing, and again decreasing. We don't have like this. We just have decreasing and increasing. In that case, let me write this thing. So third thing is decreasing, then increasing. Okay, so can I use stack? Can I use a stack? Can I think of in terms of keeping track of like max element or mean element? So can you think in this terms? If you can, like these three hints are enough to give yourself some time to come up with some solution. So pause the video and try it out for, let's say, 5 minutes. If you get something, just carry on and try to solve this. If you don't waste time. So this is kind of a stack problem. This is some pattern which you should definitely practice. If you are not able to come up with a solution after this three hints also, that is fine. That is not a problem. So after solving this problem, let's solve I can put some problem in the descriptions of stack. So make sure you can solve those problems. So you will get the idea how you can solve stack problems next time in this pattern. Okay. Okay. So now let's finally talk about the approach to solve this problem. We have enough intuition. We know okay, minimum size of array that required to us is 3. Left element, if left element is smaller than last, like the right element, that means we will not get any subarrays like this. So we can remove this part. Okay, and we can start from here, let's say, or maybe from here. Okay, we will see in stack how we'll manage this thing. Don't worry about this. But one thing to make sure, left is smaller, then we will not find more elements at that part. Third thing is we can see a pattern decreasing and increasing. Okay, let's start with a stack solution. So things will definitely become very really easy now. That is my guarantee. So let's start. I got a 3 here. Stack is empty. No need to do anything. Just put 3 here. Now I got a 2. I got a 2. What is it? This is smaller. This is smaller. This is following our pattern. Yes, decreasing. Yes, decreasing. Let me put it. Let me put it. 2. I have kept it 2. Superb. Now I got a 1 here. Now it's again 1. Yeah, this is following my pattern. Yes, let me put it. So again, superb. I got a 4 here. I got a 4 here. So now I got a 4. I got a 4 here. What is the top element in a stack? I think 1 is the top element. Is 1 smaller than 4? Yes, 1 is smaller than 4. What does that mean? That means I got one answer. Yes, I got one answer. Let me increment my counter. So my counter will be 0. I will make it 1. Super. Okay. Now I will pop it. I will again check. I will check. There are two conditions. First condition is stack length if greater than 1. Okay, if greater than 1, unless it is if equal is equal to 1, if length is equal to 1 or length is equal to 0, I will don't check. But if length is greater is equal to 2 or 3 or 4, I will check. I will keep checking. So length is 2, I will check. 4 is greater than 2. Yes, it is 2. Yes, it is 2. So I will pop it. I will increment my counter to 2. And what is the answer that I got? I think this is the answer that I got. How this is true? Because this is following the pattern, decreasing and increasing. You can see decreasing and increasing, decreasing and increasing. With a stack, I can manage this thing. Superb, superb. Now this is 4, this is 4. It's time to put 4 here. It's time to put 4 here. So let me put it. But before putting it, I need to check whether this 3 is smaller or greater, because we know, right, if left, in case left is smaller, then it will not benefit us in future. So if left is smaller, I will remove this as well. Let's say we have kept it. So again, I got a 7 here. Now I will check. What is the array size? Array size is 1, right? Array size is 1. So I will not check for this. I will not increment, because what is the minimum size that I want? Minimum array size is 3, right? So I can't, like, my current element is 7, right? So I can't compare this 7 with 4. I won't be able to compare. Okay. So I will not be incrementing this counter, but still what I can do, I can check outside the if condition. I can check whether this 4 is less than 7 or not. If this is less than 7, so I didn't get, you can see, I didn't get a decreasing pattern, I just got an increasing pattern. Like current state is this, current element is 4, so this is 4 to 7, right? So we are just increasing, we didn't get a decreasing pattern. So this means that this 4 will not help me. I will remove this 4, I will put this 7 here. Superb. Now let's move to the next element. So my next element is 5. Okay, I got a 5. Now, what is the pattern? Decreasing pattern. Yes, current stack length is 1. So I will not check for this counter or anything. But current pattern is decreasing. Yes, decreasing. So it can help me. Let me put it. Let me put it. Super. Now 6. I got a 6. So let me put a 6 here. Okay. Now, what is the pattern? I got a decreasing. Like how I can know the pattern is decreasing? If my stack length is greater than 1, if my stack length is 2, 3, 4, whatever, that means what I'm doing, I'm storing in a decreasing fashion in a stack, right? That means my decreasing pattern is there. As soon as I got one increasing element, I can start copying the elements and I can calculate my answer. So this is 5. I can definitely pop this out. I can increment my counter to 3. Superb, superb. Now I will check before adding this 6 here. I will check what is the maximum, whether 7 is max or 6 is max. I can see left is smaller, that will not help me. But in this case, left is greater. Left is actually greater. So that will be very great thing. Let me put a 6 here. Superb. I have kept a 6 here. Now I will move to 8. I will move to 8. Now this is 8. Superb. I will check what is the stack size. Stack size is 2, 7 and 6. I am having two elements. Okay, fine. So I may increment counter. How I will increment counter? I can see stack size is 2, decreasing pattern is there. Stack size is 2. What does that mean? Decreasing pattern is there. And this 8 is greater than 6. That means I got an increasing pattern. Yes, I got an increasing pattern. Superb. So I can pop this 6. I can increment my counter to 4. Superb. Now I will check whether this 7 or 8, what is smaller? Left is smaller. It will not benefit me. Let me pop it out. Let me pop it out. Okay. I will put a 8 here. Superb. Superb. Now I will work in only this part. I will put a 9 here. So as soon as I go to 9, stack size is 1. So I will not go to this counter. So this will not help me. Okay. Fine. Now I will wait. What I will do? I will check whether this stack top element is less than. Yes, it is less. So it will not help me. I will put, because I'm storing in decreasing fashion, right? So I will remove this 8. I will put a 9 here. Similarly, I will go to 10 and I will check the condition stack size is 1. I will not go and increment this, whatever happens. So I will check whether this 9 is smaller. Yes, it is smaller. I want to store in decreasing fashion. So I will remove this. I will store it at. So in last, my stack size is 10. I got a counter of 4, which is correct, because I think this is another and this one is another subarray. I hope the whole intuition is clear to you. Okay, so let's try to dry run or on one more test case that will give us full understanding of the solution. After that, we'll write the pseudocode and the code. Okay, super. Now, I will start from definitely from here. My stack is empty, don't need to do anything. I will put a 5 here. Counter will be initialized to 0. So now this is 1. Is this following the decreasing property? Yes, it is following. I will store it. Super. This is 2. This is 2. As soon as I got 2, I got increasing. My array size is stack size is 2. That means I am having at least 3 elements to compare. So what I will do, I will pop this 2. I will pop this one here. I will increment a counter. Okay. I will put this 2 here. But before putting, what I will check whether this is smaller or this is smaller. In case right is smaller, I will definitely put, because that will follow my decreasing property. Super, super. This is done. 3. I current element is 3. Now stack size is 2. Definitely I can check for this increment counter thing. Okay. Current element is greater than 2. Yes, it is following increasing. Yes, let me increment my counter. I will increment counter. I will pop this element. I have to put this 3 here. But will I put or not? I will check. 5 is greater. 5 is greater. Yes. So no problem. Yeah, left is greater. Left is, if left is smaller, then I need to remove this left part. So left is already greater, so no need to do anything. I will put a 3 here. Super. I will move to 4. 4. Okay. Current element is 4. Now I will check what is the stack size. Stack size is 2. Yes, stack size is 2. It is following decreasing property, and size, we have 3 elements to compare, 5, 3 and 4. Yes. I will check whether current element is greater than or stack top or not. Yes, it is. Yes, it is. Let me pop this. Let me increment my counter. I will put my current element 4. But before putting, what you have to check whether left is greater or not. Left is greater. Okay, very well and good. And my iteration completes and counter is 3. And that is the correct answer. We can check this 5, 1, 2, 3, 4 is giving us 3 as answer. Okay, so let's try to write the pseudocode now. I think pseudocode will be easy to write. What we need to do, we will initialize our for loop from I equal to 0 to n minus 1. Okay, and what is the next thing I need to do? I will initialize my stack as empty. Super. Okay, I need to check if my stack length, or maybe I can write more cleanly like this. If length of stack is greater than 1. Why we are checking this condition? Because I need at least 3 elements, right? I need at least 3 elements to compare, and to need 3 elements to compare, I would at least need these 2 elements, and this is the third element. So minimum stack size should be 3, right? That's why I'm checking. If stack size is 2, yes. Stack size is 3, yes. Stack size is 4, yes. But it can't be 1. If let's say my stack is empty, so I am having just this element to compare. If my stack size is 1, let's say 5 here, and 4 will come here. So do I have 3 elements? No, I don't have 3 elements, right? That's why I'm checking. Stack size should be at least 2. Okay, that's what I'm doing. What is the second condition? Second condition is, and stack dot stack dot top should be less than the current nums. Current number will be like, let's say, nums of I. So this current number should be greater. So what it is making sure? It is making sure that this is following the down property, downside. This is following the upside property. That means the third condition is getting satisfied. So yes, I can get my answer. In that case, what I will be doing, I will be incrementing my counter plus equal to 1, and counter will be initialized as 0, and I will remove the stack ka top element, stack dot top. Whatever element present in the top, I have to remove this because I have already counted this. So okay, fine. Now after computing, after this part, after this, okay, this should be in while loop. This should be in while loop. I forgot this while. Okay, this should be in while loop. We'll keep doing, keep doing, keep doing. Okay. Now in case if stack is there, if a stack, or we can say if length of a stack is greater than 0, that means what we are checking? We are checking if a stack is having any element. In case if a stack is having any element, what I need to check? I need to check whether left is greater or right is greater. In case left is smaller, so I need to remove the left, right? So what the same thing I will be doing. I will check if stack dot top, which means left is less than current, then I will remove the stack cut top, stack up top. Okay. Okay, so this thing is fine, I hope. And finally, every time I will just append stack dot append the current element. So I need to just append the current element. So in last we can simply return count. So you can see the code is really simple, but just make sure you understand these three conditions. In case you have any doubts in these three conditions, please feel free to comment down. But if you understand this three part clearly, this question will be really easy for you. What we need to make sure, three array size. How we are making sure two elements should be there, one element will be here, three array size is done. Left element should be smaller. What we are doing, before appending the current element, we are checking, what we are checking, key stack cutoff. What is a stack cutoff? What is a whatever number is on the stack cutoff, it should be less than the current element. Sorry, if it is, it should be greater than current element. In case it is less than current element, I will remove this because that will not benefit me. In last, we will just append to stack. Okay, so I hope this thing is clear. Let's try to write pseudocode for this of so the time complexity will be nearly order of n. It will not be exactly order of n because we are maintaining some stack, we are removing and adding, but that stack size will not go very large. We are just pushing every element one time and removing. So it will be nearly around 2 into order of n. I mean, time complexity will be 2 in 2n. Okay, so let me initialize empty stack. My answer or maybe counter will be initialized with 0. I will start from 0 to n because n minus 1. This is Python range function, you know. I will check while length of stack is greater than 1 and stack ka top. This is basically Pythonic way to get the top. Stack ka top is less than current. What is the current? Current is nums of I. Super. If this condition is true, what I need to do, I can increment the counter and I can remove the stack ka element. Okay, super. In case if stack is there, if length of stack is greater than 1, is greater than 0, and I can nested, I should write if stack ka top element is less than current. In case it is, so I can definitely remove this. Yes, we can definitely remove because that will not benefit us. In last, I can just append the current element and yeah, I will be done. Return the counter. Let's try to run this. It should work fine. Let's see. Okay, it is working fine. Let's try to submit this and see whether that is the correct solution or not. It is the correct solution. So I hope guys you understood this interesting stack problem. In case you did, please make sure you subscribe the channel because things will take really time. We have discussed lot of examples. See how far we came to understood this solution. So uh, I hope you understood this solution, and in case you like the video, you can give a thumbs up, and please make sure you subscribe the channel. That will be a small thing for you, but it takes a lot of effort. So thank you very much, and we'll meet in the next contest.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us.